Hey guys, it's Miss Johnson here, and I'm here to bring you your notes, the last notes for Algebra 2A. We're talking about multiplying and adding probabilities here. Now we're going to have a couple of different situations here. We're going to have to, where we have to multiply probabilities. That's when we want things to occur at the same time. But we also have probabilities that we add, and that's when we're happy with either or event. So we have to determine, do we want to multiply them or do we want to add them? So let's look up at the top. It says to find the probability of the spinning a purple and then spinning a blue. On the spinner, you would need to find the probabilities of both events separately. Spinning purple and spinning blue are independent because spinning one spinner has no effect on the other. This spinner has purple, yellow, and green. This spinner has blue and red, so they don't affect each other. There's not one in both categories. So these are probabilities that are considered independent of each other. Okay, so if I look at just the probability of spinning a purple, I have 1, 2, 3, 4, 5, 6 spots, and one of them is purple, so that's 1 out of 6. If I look at the probability of blue, over on here on this one, I have 1, 2, 3, 4 spots, and 3 of them are blue, so that would be 3 out of 4. So now let's talk about when we would multiply those and when we would add them. So if we were looking at the probability of independent events and we wanted purple and blue, this is when they occur at the same time. That means we need to multiply them together. That's when we have the probability of A times the probability of B. So here we'd have 1/6, here we have 3/4. If I want them to occur at the same time, that means I take 1/6 and multiply by 3/4, and I can reduce that. That gives me 3 over 24, or 1 out of 8. So that's when I have an and, a probability of purple and blue, and these are independent events. Now, what makes these events mutually exclusive is if I want either one to occur. So they still don't affect each other. The two events can't happen at the same time, so I can't do a purple and a blue on the same wheel because they're not on both wheels, they're on separate ones. So now if I'm happy with either or, I want the probability of purple or the probability of blue. Again, purple was 1/6, blue was 3/4. If I'm happy with either or, either one works. I only want one of them, but I'd be happy with either one. Then I take 1/6 plus 3/4 and I add instead. That's the probability of A plus the probability of B. So now I need to add these two fractions. Well, think back to adding fractions. That means I need to find a common denominator. My common denominator here would be 12. So if I change these into fractions that have the same denominator, that would be 2/12. I need to multiply by 3 here. That would be 9/12, and I get 11/12. So 11 out of 12 spins, I'd get either a purple or a blue, which I'd be happy with. So independent means we multiply them together. Mutually exclusive means we add them together. But both of these don't affect each other. Let's take a look at a couple examples. In number 1, it says at a picnic, Julio reaches into an ice-filled cooler containing 8 regular soft drinks and 5 diet soft drinks. He removes a can, then he decides he's not really thirsty and puts it back. What is the probability that Julio and the next person to reach into the cooler both randomly select a regular soft drink? So there's a couple of things here that tell me that I want to multiply these together. I want both of these things to happen, Julio and the next person. Now, what I need to consider is here's Julio, here's the next person. What are their probabilities, and what do I want to do with them? So picking a regular soft drink, that's what we want. We have to figure out how many regulars are there. There's 8, and how many total. The total soft drinks are 8 plus 5, which is 13. So for Julio to pick a regular soft drink is 8 out of 13. Well, he decides he's not thirsty, puts it back. So then the next person picking a regular soft drink would be 8 out of 13. And since I want them both to occur, that tells me I need to multiply my probabilities. So I'm going to multiply those together. That gives me 64 out of 169, which as a decimal would be 0.379. That's the probability I'm looking at. These are independent events. I wanted both things to occur, so I needed to multiply my probabilities. Let's take a look at number 2. It says in a state lottery game, each of the 3 cages contains 10 balls. The balls are labeled with one of the digits from 0 to 9. What is the probability that the first 2 drawn will be even and the third will be prime? And the third will be prime. So we want all things to occur, which again tells me that I'm going to need to multiply my probabilities. So now I need to think about how many things do I want? I'm picking out 3 different balls from 3 different cages. So I have number 1, number 2, number 3. 1, 2, and 3. So it says that the first 2 are even. So if I think about how many even digits there are, there'd be 2, 4, 6, 8, and I guess in this case we could consider 0 to also be even, because if we're thinking of either even or odd, 0 would be on the other side of an odd digit, so it would be even. So there's 1, 2, 3, 4, 5. That means there's 5 out of 10, and that's the same thing. So I wanted this to be even as well, so there's 5 out of 10 there. The third one I wanted to be prime. So I need to think about what digits are prime from 0 through 9. Well, 0 is neither, 1 is neither. 2 is prime because it has 2 factors, 2 and 1. 3 is prime, 3 and 1. 4 is not because there's a 2 in there. 5 is prime, 5 and 1. 6 is not because there's 2 and 3. 7 is prime. 8 is not, 9 is not, and then I'm into double digits. So there's 1, 2, 3, 4. That's 4 out of 10 possibilities. Now, the fact that I want all of these things to occur means I need to multiply. So I end up with 100. 5 times 5 is 25, times 4 is 100. Out of 1,000, because 10 times 10 times 10 is 1,000, which is the same thing as 1/10 or 0.1. So basically there's a 10% chance that you're going to get even, and prime when you are choosing the 3 things. Let's take a look at number 3. In number 3, it says one teacher must be chosen to supervise a senior class fundraiser. There are 12 math teachers, 9 language arts, 8 social studies, and 10 science. If a teacher is chosen at random, what is the probability that the teacher is either, it's a key word for you, a language arts or a social studies teacher? So now we're looking at either or. And the reason we call this mutually exclusive is because we're assuming that if a teacher teaches math, they don't also teach language arts. So they're excluded from each other. They're 2 separate categories. There's not something that overlaps in both. A math teacher isn't a language arts teacher. A social studies teacher doesn't also teach science, typically speaking. But now we're also looking at either or, which tells me I want to add my probabilities. So I'm looking for language arts or social studies. Those are the 2 that I want, and I'm going to add the probabilities together. So we need to figure out what's the probability of language arts and what's the probability of social studies. Well, I first have to figure out how many teachers are there total. 12, 9, 8, plus 10. When I add all those up, I get 39 teachers. There's 39 total. So out of 39 teachers, how many of them are language arts? We see 9, so 9 out of 39. For the social studies, out of 39 teachers, there's 8 that are social studies teachers. And then I want to add those up. I need to have common denominators. Well, I already do, 39 and 39, so I'm good. Add the numerators together, that gives me 17 out of 39. Turning that into a decimal gives me 0.436. Now you'll notice that I keep rounding my decimal to the nearest thousandths place, the 3rd decimal place. That's typically where you'll find probability, is it'll go out 3 decimal places behind the decimal point. All right, so that was independent and mutually exclusive events. We have to figure out, do we want to multiply them or do we want to add them? And you have to decide, do they relate to each other or not? And these all don't relate to each other. They're all independent of each other. We're going to go ahead and stop our video there at this point. And thanks for watching. Don't forget to go back to Schoology and take your quiz.